Hello everyone and welcome back to our videos. In the last video we talked about the first classification of induction system and it was the aspirated. Today we are gonna talk about the second classification, supercharger, and the last classification, turbocharger. Supercharged induction system. As the reciprocating engine aircraft climbs, the output power decreases. To prevent the loss power, more oxygen must forced into the engine, so supercharge is used. Purpose of supercharged engine-driven pump: increase the manifold pressure and forced the fuel-air mixture into the cylinder. The higher manifold pressure, the more dense the fuel-air mixture and more power output. What are the components of the supercharger? As the same component of normally aspirated air with supercharger located between the fuel metering and intake manifold. The supercharger is driven by engine crankshaft. You have to focus on the red line because when we study the turbocharger we will make a differentiate between the supercharger and the turbocharger. So the supercharger driven by an engine crankshaft through gear, a train at 1 speed or 2 speed or variable speed. The classification of supercharger: single stage and two stage and multiple stage, that depend on the number of time compression occurs. Single stage, single speed. This type known as sea level supercharger or ground post blower. The single gear driven impeller is used to increase the power produced by the engine at all altitude. The drawback with this type of supercharger: the engine output power still decreases with increase in altitude, and this feature, like the first type aspirated, the engine ratio 6:1 to 12:1. The engine operation 2600 rpm. All supercharger engine, the manifold pressure gauge sense line installed after the supercharger. The pressure of the fuel-air mixture is known before they enter the cylinder. By knowing the pressure of the mixture, more accurate indication of the engine performance is provided. As we see here, this the single impeller that of the single stage, single speed. What about the second type of supercharger? Single stage two speed. Some of the large radial engine use single stage two speed. Single impeller at 2 speed. At low speed, the impeller gear ratio 8:1. At high speed, the impeller gear ratio is stepped up 11:1. The activation switch or lever in the cockpit. Takeoff is made at low power. In this, the engine performs as the ground post engine. The power decreased as the aircraft gained altitude. As the aircraft reaches specified altitude, the control switch to high power from the cockpit. As we see in this figure, this is our supercharger, and it will take from the ambient air and it will compress it in the impeller and throw it to the engine. The impeller, how it will draw or how it will rotate. This will make it different from the turbocharger. As we see here, the impeller, it will connected with gears. Here this our impeller. It will connected by gears, and from this gear it will connected to the shaft of the engine. As we will see now, it will connected with the gearbox to our shaft, and by rotating off the shaft, impeller will drive and will make compressed air go to the engine. The last type of induction system is the turbocharger system. The drawback of the gear driven supercharger that they use amount of engine power output, so the problem avoided by turbocharger. The advantage of turbocharger: 1. Use exhaust gas driven. 2. Controlled to maintain an engine rate sea level horsepower from sea level to critical altitude. Critical altitude, it means maximum altitude under standard atmospheric condition that turbocharger can reduce its rate horsepower. When the turbocharger reaches its critical altitude, power output begins to decrease like normally aspirated engine. The location of the turbocharger between the air intake and the fuel metering system. The main component of the turbocharger is compressor housing, turbine housing, bearing assembly. As we see here, the turbine housing, the compressor housing, and the bearing assembly. The turbine assembly, it will connected to the turbine housing. By this shaft, it will extend from the turbine housing through the bearing housing and will connect the compressor in the compressor housing. And we will see this figure to illustrate the function and how the exhaust gases will move our turbocharger. turbocharger system control system. If all the exhaust gases enter to the turbine of turbocharger, excessive manifold pressure or overboosting result. To control the exhaust gases flow past the turbocharger turbine, a valve known as wastegate. The method used to control the wastegate manually or automatically. And as we see here in this figure, this is the wastegate, and we will control it manually or automatically. How we will control it manually and how we will control it automatically, that's what we will now. Manually, a manual linkage between the throttle valve and wastegate, cockpit control and adjustable restrictor. So when it connected manually, it will make linkage between the wastegate and the throttle. By increasing the throttle, the wastegate will open more, and while retard the engine or the throttle, the wastegate will close. Automatically, in this system, the automatic control system automatically position the wastegate. The engine maintain the engine power output. The main component of the automatic control system: 1. Wastegate actuator, 2. Absolute pressure controller, 3. Pressure ratio controller, and 4. Rate of change controller.